Hello YouTube, Ermin here. I want to show you how to work with arrays. And the first thing that's really important to understand is when you're talking with somebody inside of data science, and if that's your goal to work in data science or you're already working in data science, when we're talking about arrays, we're really talking about most likely Numpy arrays. So Numpy is a library that's commonly used in data science. The reason I say that is there is also an array module that can be imported, and it can be imported by typing import array as ARR. But we're going to ignore it because in data science it's not typical to use this module, so I focus on Numpy. Now, whenever you have a package like Numpy, you need to import it as well. So that's the first thing that you can do. You can import Numpy as NP. Just like this. Now, before we get into some coding, one common point of confusion is between lists and arrays. So both lists and arrays, just like tuples, sets, dictionaries, these are all data structures. And data structures are a way for us to store data in Python. You can think of data structures as containers that store data. Each of these data structures has advantages and disadvantages. So the question is then, when do you use arrays? If you plan to do any numerical operations or mathematical operations with your combination of items, use an array. If you're in science and engineering, or if you intend to be in science and engineering, Numpy is commonly used, whether it's in quantum computing, cognitive psychology, bioinformatics, mathematical analysis, signal processing, and more. In fact, you can't directly do numerical operations on a list. So let me create a simple list here. And then I'm going to try some division. And you're going to see that we get an error. On the other hand, if I create an Numpy array, again, really simple, you'll see that we can absolutely do it. So let's go ahead now and do more array operations. We'll do some simple arithmetic. One really cool thing about Numpy is that there are numerous ways to create arrays. np.array is not the only way. We can use np.ones, and by passing in an argument how many ones we want, we can create an array of ones. We can also use the random method by doing np.random.random and then passing in how many random numbers between 0 and 1 that we want. If then we want to do arithmetic like adding, we can add the values of each row, and it's as simple as doing this. Awesome. We can also carry out operations between an array and a single number, also referred to as a scalar, just like this. Great. You can also use these same methods to create more than one dimension. So you can create matrices as well with np.array, np.ones, np.random.random, and so forth, just like this. If I want to create a two-dimensional array with ones, that is 3 by 2, I can do it like this. And if I want to use np.random.random and do the same, a 3 by 2, so this would be 3 rows, 2 columns, just like this as well. Furthermore, we can do matrix multiplication by using the dot product. So I'll go ahead and create two arrays, A and B. Very simple. And then I'm going to do np.dot, and then I just feed it in the name of the two arrays separated by a comma. And there we are. How about 3 dimensions? Well, very simple. Let's use np.random.random and let's do a 4 by 3 by 2. And there we are. Now finally, and most importantly, I want to show you how arrays are applied or used in the real world. So one way that NumPy arrays are used in the real world is as part of the machine learning modeling process. So if you know data science methodology, at some point it's time to build models. If you have a regression problem, at some point you're going to want to measure how accurately your ML model is able to predict the expected outcome or the ground truth. So you'll want to use something called a loss or cost function. One of those cost functions is called the mean squared error. It's often the default metric for this type of evaluation. So let me show you how to use it. I'm going to create array1 equals np.array, and I'll just pass in 1, 2, 3. And then I'll call or create a second array, array2 equals np.array, and I'll pass in 4, 5, 6. So then it's just a matter of knowing and using the formula for mean squared error. So I'll type MSE equals opening parentheses 1 divided by 3 closing parentheses times np.sum. So this is one of the mathematical methods of NumPy. Opening parentheses np.square opening parentheses array1 minus array2, so the difference between the two arrays, and 2 closing parentheses, and then next line MSE, and there is our result or output. And finally, thinking more big picture, I want you to think when it might be suitable to represent your data as an array. So one common use case is to use NumPy arrays to represent images. So think about a black and white image first. Each of these pixels is represented by a single number between 0 and 255. If the image is colored, on the other hand, then each pixel is represented by 3 numbers, a value for each of red, green, and blue. In that case, we need a third dimension because each cell can contain 1 number. So think of an image with color as having a particular height, width by 3 dimensions. So what I want to do now is read in an image and show you that underneath the image is just a bunch of numbers. It's an array. So we want to reduce, and we do reduce things like images and images of a nice cute puppy to numbers so we can do computations on them. And we can manipulate that picture. So I'll show you exactly what I mean. So I'm going to import something called CV2. And then I'm going to do img equals cv2.imread, and then in parentheses with single or double quotations around, the name of the image is pop.png, and then plt.imshow, and then pass in the name of the image, img. And look at this beautiful pop. Now, when I print this image, so print and then pass in image, notice that it's just a bunch of numbers. It's those numbers we talked about, 0 to 255. And we can also confirm that we're dealing with a NumPy array by using the type function. So just type and then pass in the name of the variable that's storing the image, so img. And there we are. And we also want to check the shape of our image. So to do that, img.shape. So we can say this image has 250 rows, 250 columns, and 3 dimensions. So then the image resolution can be looked at as 250 by 250. So now we can use these numbers to manipulate the image. So I'll type trim_me equals img, and then in square brackets, I'm going to do 15:250, comma, let's say 3:250, closing square brackets, and then print, opening parentheses, opening square brackets after trimming, colon, closing square brackets, comma, trim_me dot shape. I just wanted to print the shape that we have after trimming or cropping. And there we are. So it prints now what the trim looks like, how much we've cropped it. Now it's a 235 by 247 by 3 image, and I can show you the image, plt.imshow, and then pass in trim_me. And as you see, it's perfect. Now, if you don't have any experience with indexing and slicing with Numpy arrays, this might look a little bit confusing. I won't go into too much detail, but all I will tell you is that these numbers here, so this represents the starting row essentially to the ending row. Remember that we have 250 in total. And then there's a comma, and this is in regards to the column. I want to start at the third column and go to the 250th column. Why? Well, if we take a look at the initial image, you can see that we have a little bit of space up here. This is actually a well-cropped image. It's actually cropped too much when you think about it because the full image of the pup is not there. But that's not the point. Point being here that there's a little bit of space in terms of the rows up here. We could get rid of that and make it even more cropped. So what I said was, well, if I look in terms of the rows, his head, the top of the pup's head, is basically around 15. So then that's why I say 15 to 250. And then if you look at it from a column perspective, so think about the columns going straight down like this, well, it's pretty much cropped. You can't really do too much here, or you're not going to see this purple ball here if you were to crop too much. So I just put 3. So it's a very, very small little difference from the initial. But that's really all there is to it. There's no specific function to do the trimming and cropping of an image. But there are other functions to do other types of image manipulations with Numpy. So that will do it for this video. The bottom line is, if you are or will be in a field that has a component of numerical computation, you want to get acquainted with Numpy arrays. Please share and like the video, and if you have any questions, feel free to ask below.